Hello and welcome back. We'll continue with part 2 of section 1.2 on data. And in this video, we'll look at levels of data. So there's a natural hierarchy to how much information you can discern from data. And the lower levels, you don't get as much information from them, or you get maybe a different type of information, but the further you go down on our list, the more information you can glean from the numbers in the data. So the types of, the levels of data are nominal, ordinal, interval, and ratio. And nominal data is going to be categorical data. It's something where the information is going to be what category does some object or some information belong to. But in particular, nominal data, the order of the data doesn't matter. You don't get any extra information by placing the data in some order. Once order does matter, you jump into the ordinal level of data. So in ordinal level of data, you can order various bits of data, either parameters or statistics, and you can order that, and it has some meaning to it. But maybe the differences between the different levels are a little bit meaningless. So here I want to quickly do a couple of examples. So say with the nominal data, it could be something like colors, like eye colors or colors of flowers. Here we can't order colors in some sort of meaningful way in the sense, or names of people. The order doesn't give us any extra information. Whereas, for instance, ratings, when a movie is rated 2 stars out of 5 or 3 stars out of 5, we can put these in order in how they were rated. In the same way with rankings, if a periodical was going to rank, say, the best universities, this information can be put into some order, but the differences between different places in the ranking doesn't matter, or doesn't have any extra information. The difference between first place and fourth place has no relationship between the difference between 7th place and 10th place, even though they're both 3 places apart. 3 places apart doesn't give us any extra meaning in here. Once that does, we jump into the interval level of data. So for instance, for the interval level, we can have something like temperature. And again, if we were going to take temperatures of water at various places, and in one place the water is 20 degrees, and in another place the water is 30 degrees, yes, we can order these. And the difference between these temperatures has an inherent meaning. The difference between 20 degrees and 30 degrees is 10 degrees. And if I were to measure water in another place, and it was 55 degrees, and another place is 65 degrees, that difference of 10 means the same thing in both contexts. The difference between the measurements has meaning, which is the interval level. Now there's one more level, and the easiest way that I can think of to discern the difference between interval level and ratio level is that the interval level ratios are meaningless, and one of the easiest ratios to remember is twice, is just 2 times something. So if I were to measure water at 20 degrees and measure water at 40 degrees, it doesn't mean that the water at 40 degrees is twice as hot as the water at 20 degrees. This twice in there, having a number that's 2 times bigger than another number, doesn't really give us any extra information. For ratios, this does. And an example of information at the ratio level, data at the ratio level, will be, say, lengths or volumes. If we were to find a snake that was 1 foot long versus a snake that was 2 feet long, that's twice as long. And the difference between them, 1 foot, has meaning, so we're clearly at the interval level, but we have more information because that twice has meaning. Another thing to keep in mind at the ratio level is that 0 is a natural starting point. So if we were measuring, say, lengths of things, if something is 0 feet long, that has a very particular meaning. It means that it doesn't exist. It's not there. It doesn't have any length. So 0 is another nice way to see if something is at the ratio level, whereas 0 degrees, say Fahrenheit, although it means something, 0 doesn't mean that there's a lack of something. The 0 there isn't the starting point. We can go below 0 as well. If 0 is the absolute starting point, it's probably going to be at the ratio level. So I want to do some examples, some more examples. This should help a little bit more. So here, our first example will be grades. So when we look at what grades a student can get, for instance, get an A, B, C, D, or F, and we want to think about, okay, which level are grades going to be at? So we should remember that we've got nominal data, ordinal data, interval data, and ratio data. And when we look at this, we can say the first thing to consider is whether or not we can order these. And clearly, we can order these. An A, we can order them in sort of the grade that you'll get. An A will be better than a B, which is better than a C, better than a D, better than an F. So we can order these grades. So these are at least at the ordinal level. But the question is, could they be at the interval level, at the next level? Well, the difference between an A and a B, that has no meaning, because the difference between a D and an F is also, there's no inherent meaning in the difference between an A and a B and the difference between a D and an F. So this is going to be at the ordinal level, because we can order this data, but the difference between points in this ordering doesn't really matter. So here we have the time it takes to finish a race. So again, you could finish a race in, say, 2 minutes, or in 4 minutes, 6 minutes. So we can order these clearly. And the difference between times to finish a race is going to be, has some meaning. If someone finishes a race in 2 minutes versus 3 minutes, the difference between these guys, the 1 minute difference, has an inherent meaning, and we can we can see that. So this is going to be not only at the ordinal level, but it'll be a little bit, we can glean more information from this. So it's at least going to be at the interval level. But furthermore, if we want to think about ratios, twice is a nice thing to think of. If we could it take twice as long to finish a race? Yes, that makes sense. The difference between 2 minutes, say, and 4 minutes to finish a race, well, that's twice as long, and this makes sense in context. So this is going to be at the ratio level. Also, we can think about 0. If it took 0 minutes to finish a race, oh, you got to the end instantaneously. You teleported there. So this has a meaning associated to it. So this is going to be at the ratio level. The next one, answers to a true-false question. Well, first thing, can we order these in any meaningful way? Can we order true and false? Well, the order that we put these in doesn't make a difference. Putting true before false or false before true, these are just names of categories. So this is going to be nominal. And then lastly, the year that an event occurred. Well, we already saw that time up here was ratio, so maybe down here, since years also measure time, maybe this is also ratio. So we can think of, is the year 1000 and the year 2000, Was the year 2000 twice as far into the future as the year 1000? Well, twice as far of what? There's no twice. This doesn't really make sense. Another thing to think about, was 0 the starting year? No, we have historical documents from before 0. The Earth was around longer than that. So 0 here, while it has a meaning, it's not the starting point. And because it's not the starting point, this is going to be at the interval level. Again, we can order years, so it's clearly going to be at least ordinal. But the difference between, say, 0 and 1000, and the difference between 1000 and 2000 means the same thing. Differences have a meaning, so this is going to be at the interval level. I think that of everything that we've done so far, this is maybe the trickiest, so please let me know if you have questions.